Session 2016, determination of the characteristics of an electric component. So we have here an electric component D, and which is an unknown nature, which may be a resistor or a pure coil or a capacitor. To determine the nature and the characteristics of D, we consider the following. So we have an ideal generator of electromotive force E, two resistor R1 and R2, and a double switch. So we have the circuit in the figure. In the next figure, we continue now. First experiment, at t equals to 0, the switch K is turned to position 1. So here, in this position. And so the figure 2 shows the variation of the voltage UFM across the terminals of D as function of time and the tangent to this curve. The component D is a capacitor, justified. So as I'm طلع figure, the voltage is increasing from 0 to a value which is a limiting value, which is 12, so it's a maximum. This means it's a capacitor, so justify since the voltage is increasing, and it's not increasing as a line, is increasing as an exponential. So exponentially. Now, لو كانت increasing as a line كانت هتكون عندي a resistor. So increasing exponentially with respect to time. هتوصل to reach a constant value, which is the limit value, the limiting value. Indicate the value of the electromotive force of the generator. So we know that for a capacitor, at the end of the capacitor, we have UC maximum is equals to E. So, and we know that by the figure, we have UC maximum is equals to 12 volt. So we continue. Calculate at t equals to 0 now the current carried by the circuit. In order to find the current, we'll do the law of addition of voltages. So we have E is equal to UC plus UR1, which means that E equal. Now we want to find at t equals to 0. At t equals to 0, the capacitor was uncharged, so it's equal to 0 plus R1 times I0, which means that I0 equals to E over R1. It's equals to 12 over 100, which means it's 0.12 ampere. The next part, derive the differential equation in terms of UC. So in order to find the differential equation, we start with the law of addition of voltages, which means that UG equal UC plus UR. This means that E equal UC plus R1 times I, but we know that I in the case of charging, CQ over dt, which is C duc over dt. So we'll substitute here, plus RC duc over dt, and we divide by RC, then the equation will become duc by dt, plus UC over RC is equals to E over RC, and that's the differential equation. Part 5, so this is 4. The solution of the differential equation has the form, this is the form. Determine the expression of the constant A, B, and tau. Since this is a solution, this means it's verified the differential equation. So نحن معنا UC, but we still have to find duc over dt. So UC equal minus T over tau. So we'll do a derivative first. A is a constant, so derivative is 0, plus B between bracket minus 1 over tau, E minus T over tau. And then now we substitute in the differential equation, which means that we'll get minus B over tau, E minus T over tau, plus UC هي هيدي كلها بنقسمها على RC. So plus A over RC plus B E minus T over tau على RC. And كمان بنجيب هيدي لهون. So minus B over RC is equal to 0. Now, if you want exponential, we take as common. So في عندي هيدا البارت. We have common B E minus T over tau. بيبقى لي من أول وحدة 1 minus 1 over tau, and from the second plus 1 over RC, plus these two, if you بيناتهم common 1 over RC, so we'll get A minus E equal to 0, which means that minus 1 over tau plus 1 over RC equal to 0. This means tau equal to RC. So هيك نكون طلعنا أول unknown. The second one, A minus E equal to 0, which means that A equals to E. And the last unknown اللي هي B. Now نطلع last unknown اللي هي B رح نستعمل the initial condition. So initial condition, we have at t equal to 0, UC was uncharged, which means that by substitution, we have UC equal A plus B E minus T over tau. This means 0 equal A plus B e to the power 0, which is equals to 1. يعني A equal to minus B. يعني B تطلع معنا equal to minus E. Then هيك بنكون طلعنا 3 unknown. Now here in this part, determine graphically the value of time constant tau. Now بما إنه قسمنا tangent, so we use the tangent. So in this part C6, we'll say that the intersection of the tangent to the curve at t equals to 0 with UC equals to E is at t equals to tau, which means graphically, so here we have the intersection, so this means graphically tau equal to 2 seconds. Reduce the value of C. We know that tau is equal to R times C, which means that C equal tau over R. We already have R, so we'll get equals to 2 over 100, which is 0.02 farad. Then this will be C. We continue. Now the second experiment, we put this is the capacitor here. Now we put it, it's already charged. We put it in a circuit where there's no battery. So we name the phenomenon of that take place. So it's the discharging of the capacitor. Now the resistor R2 can support a maximum power of P maximum equals 0.24 watt. Calculate the maximum value of the current which can pass through R2 without damaging it. In order to find the maximum current, so we have P equal for a resistor, the power can be written in the form P equal Ri squared. So here this is part 2, a P maximum equals to Ri maximum square, which means that I maximum square is equals to P maximum over R2 here working, so it's 0.24, and R2, which was equals to, so we already have it, R2 equal, so let's see, 150 ohm. So it's over 150. Then we'll get that by radical that I maximum is equal to 0.04 ampere. This is the maximum current that can pass through R2. Applying the law of additional voltages show that the maximum voltage across the terminals of the capacitor equal to 10 volts, so that R2 will not be damaged. So نحن بدنا ال R2 ما يكون damaged. So we'll now apply the law of addition. So we have U of the capacitor here is equals to U of R1 plus U of R2. And for the capacitor, for the resistor not to be damaged, we must have the current here is equal to 0.04. So this means R1 times I write to I maximum, plus R2 times I maximum, which means is equals to R1 plus R2 times I maximum. And we have 150 and equals to 100, so it's 250 times 0.04. So we'll get here as answer 10 volts, so it's verified. Part C, at the instant T1, the current is maximum. Determine graphically the maximum duration delta T equal T1 of the charging process of the capacitor so that the resistor R2 will not be damaged. So for the resistor not to be damaged, okay, قلنا نحن على أول شيء على graph what we have. So we want to find the questions to find T1. بس نحن على graph we don't have the graph of the current. لو عندي graph للcurrent بحط, for example, if I have the graph of the current I, then I will say the maximum current will be 0.04. So إذا معي current بحط 0.04 بطلع time. But I don't have the current. I have in the graph UC. So this is why كان سألنا بpart B when when R2 is not damaged. So عرفنا for R2 not to be damaged يعني لازم يكون عندي UC is equal to 10 volt. So بطلع على graph and I find UC is equal to 10 volt. This is UC equal to 10 volts. This means the time T1 is approximately this value اللي هي تقريبا this is for example معناها it's this is 2, this is 3, so تقريبا is 3.5 seconds. Then here we'll say that T1 is approximately 3.5 seconds. This is for UC equal 10 volt.